Okay, now we're looking at a confidence interval for a paired t-test. And this is the same scenario as the one for the hypothesis test. So I'm not going to go through and read the scenario. But again, they're just trying to figure out, hey, where does the actual population mean lie? Because all we have is a sample. And we have the sample of the 12 students, dominant, minor, and we need to sit there and start off by beginning by defining what is our mu d. So our mean difference in this case is, once again, let mu d equal the true population mean difference in reaction time and once again I'm going to go with dominant minus non-dominant. All right, and so they're asking me to create a confidence interval, and so I need to go through my conditions, but since we already did that, I'm going to say conditions met, see page 141. That way it speeds things up for us because we don't need to redo what we've already done. All right, so I've entered all the data into StatEdit, and the original data, the dominant hand was an L1. This is an L2 represents a non-dominant hand. And then I need to find out the differences. Well, I did that previously, but we'll do that again. So I went second L1 minus second L2. So there it populated the differences. I'm going to go to StatEdit, or StatCalc, one variable statistics, and I'm interested in the differences, which is an L3. And we find X bar equals 0.0132. And we also find our standard deviation of the sample is 0.0164. We need our degrees of freedom, which is n minus 1, or 12 minus 1, which is 11. So we have 11 degrees of freedom. All right, so confidence interval. The confidence interval is going to follow the formula X bar D plus or minus T star, the standard deviation of the difference, divided by square root of n. Well, I'm going to plug in what we know already. So what we already know is that this difference is 0.0132 plus or minus. We'll leave a space for T star because we don't know that yet. So I'll leave that space. And my standard deviation of the difference is 0.0164 divided by the square root of 12. All right, not the square root of the degrees of freedom, the square root of the sample size. Well, I need to find T star. Well, first off, that's going to depend on what my confidence level is, which in this case is 97%. So we need to find 1 minus 0.97 divided by 2. So the easiest way to go through this process is second vars inverse t. So second vars inverse t, press enter. The area is parenthesis 1 minus 0.97, close parenthesis, and divide that by 2. And our degrees of freedom are 11, or 12 minus 1. So we end up finding a T star of 2.49. All right, and so basically if I were actually drawing a picture of this, so for understanding purposes, this is 97%, and I'm looking for this value and this value, and we know that this is going to be centered on X bar, which in this case was 0.0132. So this is what we're finding is, hey, we believe, or we're 97% confident that the mean's going to lie somewhere in between here. So stat test, and we're going to run a t-interval, which happens to be number 8. Again, we're going to make sure use our data, so our data is highlighted. Go to L3, our frequency is 1, and our confidence level needs to be 0.97. It's really important to use a decimal point there. And we end up getting this interval, negative 0.025, and by the way, negative 0.025 to negative 0.00141. What we just found is this is x1 and this is x2. All right, so we know that we're not containing 0. All right, so we believe that it's below 0. So in other words, that difference is negative. So in this case, we need to state our conclusion. And it says, we are 97% confident that the true population difference in reaction time DOM minus non-DOM lies within the interval negative 0.025 comma negative 0.0014. All right. Now, they also said explain the confidence level. All right. So we need to explain our confidence level. So our confidence level in this case was 97%. So if we did this over and over again, so in repeated sampling, we are 97% confident that the true population mean difference in reaction time lies we are not, I'm sorry, I messed that up. And repeated sampling, start over. And repeated sampling, we expect that this method will capture the true population mean difference and reaction time. How often? Well, our confidence level is 97%, so reaction time 97 of the time. One other thing that we should note, in this case, 0 does not lie in the interval. Because it doesn't lie in the interval, we believe there is a difference in reaction time. So 0 does not lie in the interval. There appears to be a difference in reaction time. It appears that the dominant hand is faster. Dominant is faster than non-dominant. So once again, this right here represents the conclusion. We are 97% confident that the true population difference in reaction time, dominant minus non-dominant, lies within the interval negative 0.025 to negative 0.0014. And then explaining the confidence level, in repeated sampling, we expect that this method will capture the true population mean difference in reaction time 97% of the time. And then lastly, they didn't ask this, but you need to understand, because 0 does not lie in the interval, there appears to be a difference in reaction time. Dominant is faster than non-dominant.